everyone, we're going to verify trig identities, inverse trig identities part 2. The first thing we want to deal with is our inverse, so I'm going to write this, set it to theta. We're going to let that equal our angle, so V equals cosine of theta. And with that being said, we know that our restrictions, you have to write your restrictions down, we're in quadrants 1 and 2. So we're in between 0 with the inverse cosine, or cosine inverse. All right, so basically let's start dealing with this. We have that tan of inverse cosine of V equals tan of theta. So the theta is coming from this right here. I'm letting this equal what? Theta. Okay, we'll substitute later. So now we have sine of theta over cosine of theta. All right. For sine, I already know that cosine is V because we said it there. But what I'm going to do for this part is write this as 1 minus cosine squared of theta. And again, I'll write it over here. Square root of 1 minus cosine squared of theta is the same as the square root of sine squared of theta, which equals sine of theta. So I'm trying to make it look like this, and I just rewrote it. So basically what we're going to get is my cosine is V right here. So I have equals 1 minus V squared over my V. Basically, I'm just writing this in terms of sine and cosine. Okay, the next one, I'm going to set this to theta. So I have, and I know that cosine, basically cosine inverse V equals theta, so V equals cosine of theta. Now, I'm going to go ahead and write that again. So we have sine of cosine, or inverse cosine of V equals sine of theta. Okay, so there we have, I know that this part here equals my angle, which is right here. So I just rewrote that. Now, I'm going to, for this part, just remember on the restrictions, we're in between the second quadrant, the first and second quadrant, the upper half. And when I write sine, I'm going to write sine as, because I have cosine here, as 1 as sine squared, which equals 1 minus cosine squared of theta. So this is going to be the square root 1 minus V squared because of this right here. So I just rewrote it in terms of cosine. Okay, and the next one, same thing. I'm going to let this be my angle. So I have, so basically the sine of my angle equals V, where the restrictions are in the first and fourth quadrant. And then I'm going to go ahead and write this as cosine of sine, inverse sine of V. We're letting this equal my angle, which is right here. It's my angle. So this equals cosine of my angle. And I know that I can write cosine as square root of cosine squared, which is the same as square root of 1 minus sine squared. Well, I know that sine equals v, so I'm going to write this as 1 minus v squared instead of sine squared. And the last one is this one. It's getting easier yet. Okay, so I'm going to let this be my angle. So I have 10. That's my theta. So v equals tan of theta, where my restrictions are between negative pi over 2 and pi over 2, exclusive of these. Now, I'm just going to write this out. I want it to look like this, so I have cosine of tan, inverse tan of v equals cosine of theta. All right? Now, I know that I need this, so what I'm going to do here is let cosine equal, right here, I'm going to move it down here, 1 over secant, because I have a 1 right here. Now secant is 1 over cosine, so basically I'm going to write this as 1 . I can write the secant as secant squared of theta, because these two match. All right? And then when I write that, I know that this equals secant squared is, and I'm trying to deal with tan here, because that's the information I have. So secant squared is the square root of 1 plus tan squared. So now we have 1 over the square root of 1 plus, and tan equals v. So that would be v squared. All right? Thank you and have a nice day. Bye-bye.